Well, it'll be a short poll tonight, but if you all could just answer whether you've actually used data analysis software in your studies or work and what your area of study is. And that'll give me a little baseline on how to tailor the presentation this evening. Okay, well, great. Well, that was just to give me and you also an idea of where we're starting from in terms of using data analysis software. Let's go on to the presentation here. Well, thanks for showing up online on Halloween evening. You know, we're living in an interesting period in terms of software that's available for research. In fact, it's just been in the last few years that software has really permeated research, and you'll be hard-pressed nowadays to find science, hard science or social science research that does not utilize some sort of software for data collection, data analysis, or data presentation. When I went to graduate school, at least the first time, originally, you know, there were just a couple of data analysis software packages that were available, and they were fairly rudimentary analysis applications that didn't have really great visualization tools, and there were just a couple of them, really, 2 or 3 major packages. And it was assumed if you were going to do really hardline research, you were going to be using one of those. Today, it's a little different. We have so many software packages to choose from that selection of the right package for your research is now an issue that new researchers have to face. I'll just get my presenter toolbar up here. Hang on just a second. So let's start by talking a little bit about software skills that researchers need to have these days. Certainly, you need to be able to use the analysis packages that we're going to talk about in the presentation tonight. But as I mentioned, being able to evaluate and select the right package is certainly an important skill. And if you're doing research in the physical or natural sciences, also hardware device selection is important, especially if you're collecting data through any automated means that requires sensors or any data collection devices. In addition, for a variety of purposes, all researchers need general, and advanced user skills in regular desktop software like Microsoft Office, for writing grants, tracking budgets, personnel, staff, etc. And of course, nowadays, because we have more and more federal and private funding agencies that are requiring data management skills and data management components to research grants, data management skills are very important. So not only being able to use the software packages for data analysis, but how do we preserve the data files long-term so that they can be accessed publicly. So for example, if you get a National Science Foundation grant, you'll probably be required to post your research data in some sort of public forum at the end of the grant period. Certainly you're going to have to make your data available, and you're going to have to preserve it, and you're going to have to tell the National Science Foundation the steps you took in order to preserve it. So data management skills go hand in hand with research software analysis skills. Now, I pulled a couple of job descriptions that are current. In fact, they're current as of this week for both hard science and social science positions. And this one here is, if you're familiar with Data One, which is a research data repository sponsored by the University of New Mexico. They're actually advertising for a postdoctoral climate scientist. And if you notice what's highlighted in red in the position description here, they want expertise in advanced interactive visualization techniques, data visualization. They want you to be able to use specific visualization software packages. And down here, they want somebody who has some sort of scripting or programming experience. If we go on to the next job description, this is for not an entry-level, but close to an entry-level social scientist position with the U.S. government. And if you'll notice what's highlighted in red down at the bottom here, the ability to utilize statistical software such as Stata, SPSS, SAS, etc. So really, both natural science and social science positions that are available out there are all going to require some level of software skill, especially with data analysis software packages. Now, it's also important to have skills with applications that support research, even though they aren't directly tied into your data analysis and data collection part of your research. So project management software is something that can be very useful in a research project. Being able to use at least essential skills in packages like Basecamp or MS Project, or being able to publish findings in notebooks and training materials on wikis and blogs, or if you work in a lab environment, being able to use an electronic lab notebook, are important skills to be able to learn in order to manage the entire research process, not just the analysis process. More and more workflow software is finding its way into contemporary research projects. Workflow can be simply the matter of diagramming how data is going to be collected or preserved or analyzed in a sort of a systematic format, or it can actually be dynamic workflow. So if you work in experimental research, you are probably familiar with electronic workflow systems like MyExperiment or the variety of Kepler-based workflow tools that actually help you build and automate workflow processes for experimental research. And then, as I mentioned previously, being able to have office application skills for general administrative duties that are related to managing a research office or a lab or a grant, etc., are still very important things for all researchers to have. Now, there's a variety of ways that we can categorize data analysis software in particular. Now, we could do it by discipline, but a lot of the packages that we're going to look at this evening cross over multiple subject disciplines in their usability. And so I've tried to organize them more along the line of, and actually let me go back one here because I think we skipped it fully. Tried to organize them more along the line of the type of research activity that each of these packages is primarily used for. So of course we have software packages for qualitative analysis, and quantitative analysis. Most function extremely differently, in different ways. If you're in the social sciences or in the humanities and doing digital humanities research, content analysis is also an important component. If you're doing natural science research or any type of scientific research that involves observation and field data collection, then data acquisition software is important. And of course, we're finding that geographic software that provides some sort of geospatial context to data is finding its way into every scientific discipline these days, and is used in almost every subject area, from the arts to the humanities, social science, and physical and natural sciences. There are packages that primarily do higher level mathematical functions. Nowadays, visualization is an extremely large and growing area of data analysis software design, and modeling and simulation is one important part of that, both in terms of abstract modeling and actual virtual environment modeling. So there are a wide range of programming languages, or at least scripting languages, that are useful in data analysis as well. And there are several of these languages that were actually written originally for research analysis purposes. As I mentioned, visualization, very important, especially these days when we have so many different advanced ways of looking at data. And then there's a whole plethora of specialty applications, and you can find a specialty data analysis application for any subject, any discipline. All you really have to do is Google data analysis and whatever your particular subject, specialty, or area of research interest is, and I'm certain that you can find at least a couple of applications that were written specifically for what you are interested in analyzing. As I mentioned, being able to select and purchase data analysis software is an important skill that that new researchers have to master. Now, previously, it was enough to know that your software, your analysis software, could be used during the analysis phase of the data lifecycle here. But really, because of federal funding requirements and data archiving requirements, both for grants and for publication these days, you really need an analysis application that can be used throughout the data life cycle. So if you've seen the data life cycle model before here, essentially on the right-hand side of the cycle, we have data collection, quality assurance, description, and then finally preservation. Those are the initial stages of research, any research project. Then on the left-hand side here, we have the analysis phase of the research process. Really, we need to use the data analysis packages that we're going to look at for almost all of these phases here. So the proper data analysis package is important to the preservation stage, so that you're able to output your final research data, for example, in a format that's going to be accessible long-term for others who are going to need to use your data. We need metadata and documentation capabilities in the data analysis software so that it can be properly described, so that users later on can either review your work, as in peer review, or can actually make use of your data if it has to be made open access. And then certainly the core analysis parts of the research process are what the data, the analysis packages are written for originally. So you need to ask the question, does the package that you're picking for your research project meet all of the needs that you'll have for it throughout the research data lifecycle? Now, I used to have a metal shop teacher in junior high school who used to hit home with us all the time this tired old adage that you need to use the right tool for the right job. That's kind of what we've been talking about in terms of selecting data analysis software. Just make sure it fits exactly the purpose you need, and there's a wide variety of tools, as you'll see in just a minute. One thing you need to be aware of, certainly, is that both basic and specialty applications for data analysis can be very expensive. So some of the packages that we're going to look at tonight are free and open source, and that's what you should look at first to make sure that you have identified all of the low or no cost alternatives for the kind of package you need to use for your research. There are also some free web-based tools or cloud-based analysis tools. There's one or two that I will cover tonight that are around that are certainly good alternatives, at least for basic data analysis. And then I've earmarked the particular packages that we're going to look at that have UNM has negotiated licenses for. That means you can get free or low-cost copies of these packages, and all of them are really good analysis packages that you can use for a variety of different research purposes. And then a number of them also have educator or student prices that you should look for before you buy, of course, before you pay the full commercial price. Now, there's a whole different other class of specialty data analysis tools that are more large scale or enterprise class that we're not going to look at tonight. Those tools, while they are interesting, are really tools that you can only afford if you get a grant for them. So some of the one of the questions I had in the last workshop was about video analysis, and there are a number of video analysis tools that can be used for social scientists or business and marketing analysts that are excellent, but the licensing fees are going to cost over $100,000, for a single copy on those. So I've limited what we're going to look at tonight to desktop applications that you should be able to afford at least a basic copy of the tool on your own without having to get grant funding. Let's start and first look at the class of applications that we would call qualitative analysis software tools. And here's two screenshots from several of the more popular tools. One is doing a iconography analysis or content analysis of a painting, and the one on the left here is actually doing a video interview analysis, so an interview analysis. Oops, let's go the right way. So the types of features, if you're looking at a qualitative data analysis package, that you would want to make sure that you have, since so much qualitative analysis deals with marking up and coding behavioral or verbal interview responses, we need online codebook management. We should also have point-and-click coding so that you can scroll through the transcript of an interview, for example, or the notes from an ethnographic survey, and you can simply click on individual responses that meet certain code criteria that you've defined, and it will insert your codes without you having to manually, in older software packages, especially the qualitative type, you actually had to insert your coding manually, your code marks. There are also a lot of tools that will do auto coding. So if you give if you create the operational definitions in the software for your codes and feed transcript information into the software, it should be able to at least pick up some codes automatically and mark them without your having to analyze the text manually. You should be able to do also margin notes and extensive annotation. And you should be also be able to weight your codes so that you can mark which responses are really significant as opposed to marginally significant responses in your interviews. So much of qualitative research is done using audio and video these days that being able to handle multimedia files is extremely important for those qualitative packages. And having transcription tools. Now, none of the tools we're going to look at actually have automated transcription capabilities, but they do have tools that will help you, for example, synchronize a video, a copy of a video, an interview video, and the text transcript of that interview. And sync them together so that you can play the video back and scroll through the same parts of the transcript and keep them synchronized that way. If you're doing sort of pure classical style sociological type surveys that include a lot of survey instruments with Likert scales and so forth, then having embedded survey management tools in the software is important. And of course, all data analysis tools need to have great summarization and reporting capabilities. Now here are three major qualitative analysis packages and one content analysis package. Now, my background is in information science and anthropology, so the primary form of qualitative analysis I've done myself has been ethnographic surveys. So Atlas TI is used extensively through the anthropological profession and also in marketing analysis and information science in terms of like computer usability study analysis. And it's a really full-featured package that will do all sorts of qualitative analysis. They also have a great, as I'll show you in a second, they have a great student pricing rate that you can take advantage of. So I'm personally a big fan. NVivo and QDA Minor, QDA of course stands for Qualitative Data Analysis Minor. Yeah.
Oh, I just wanted to remind folks that we have Atlas TI here at the Graduate Resource Center for free for students.
Excellent. That's great. That's good because UNM doesn't have like a campus-wide negotiated license for Atlas TI, which is really great to know that it's here in the GRC. NVivo and QDA Minor have a number of more verging on quantitative analysis capabilities built into them. I've noted that NVivo is used by a number of health sciences researchers who are doing some sort of patient-centric or behavioral research. The same with QDA Minor. Now, if you're doing for either social science or humanities research, content analysis, where you actually are scanning large collections of documents and need to be able to identify patterns that are similar within each of those documents, using a content analysis package like Lightside, which is free and open source. It's also produced, I believe it's produced by Cornell, if I'm not mistaken. But you can get that package for free, and it lacks some of the advanced features that commercial content analysis packages provide. But the fact that it's open source and that it's used and designed by researchers who need good content analysis tools is a big plus. So I was going to talk a little bit more in depth about Atlas TI, and it's great that it's free here in the GRC. Like I said, it's used extensively in anthropology and all of the social sciences, business and marketing, as well as computer use studies. The Atlas TI interface is shown down here in the bottom right corner. You can see on the left we have our text analysis interface. Then we can add multimedia windows for audio and video on the right-hand side there with playback functions. And Atlas TI also, the basic package includes some visualization capabilities. It does include a basic geospatial data capability, but there are also add-ons that you can purchase to enhance those capabilities. And it's available on both Mac and Windows, but not on Linux right now. Here's a zoom in of the Atlas TI interface. What I mentioned before, code book management, this is the online code book tool, and each of these terms that are highlighted inside the window are the actual codes that have been defined for the particular survey that's going on here. Once you've done your markup and you've actually marked the text back here with your codes, you can do a variety of different visualization scenarios that allow you to see the relationships between the different documents that you are analyzing, or different parts of documents, like different sections of an interview, for example. So that you can see where the threads between the different coded responses are being made. And over here, this pane in the right-hand side, you can see this is where the point-and-click coding comes in, where you can just highlight a section of text and mark it with a code, and then the application actually tracks what sections of the text you've marked with your survey codes. Then over here in this window, you can see there's a pull quote manager that allows you to identify really significant responses within the interview text and save those for easy later reference. So that if you find that somebody gives a really pertinent response or a really significant response that you want to drill down and analyze further, you can save those sections over here for further analysis. Here again, some of the features, a larger view of the relationship visualization feature. Here's a view of the basic geospatial mapping capability that's available on Atlas TI. So let's move on and look at some quantitative analysis software packages. The kinds of feature set that you want in a quantitative analysis package include mathematical functions and statistical functions, including the ability to do regression analysis, multivariate analysis, survey data analysis. You know, it's important sometimes in research, especially social science research in psychology and so forth, to be able to do a quantitative analysis initially and then take the marked up results, the coded results, and translate that into a quantitative analysis package, especially if you're trying to do analysis over a large population study where you've had a lot of responses and you're trying to get to identify sort of mass patterns and trends in those responses. So these are some of the major functions for quantitative software that you want to look for. Now we've got three major commercial packages here, and we've also got Microsoft Excel listed. Now the packages listed here can be a little pricey. I know a number of researchers who use StateUp. I've never used it myself, so I'm not going to talk too much about that. But as an entry-level researcher, certainly for basic quantitative analysis, if you need basic mathematical and statistical functions, Microsoft Excel will do fine, at least at the outset. And in fact, Excel, the Excel data format, the spreadsheet format, is so universally used that even if you're using another analysis package, you may need to transfer data or post data, publish data in Excel format simply because it is so universally used. I've heard a number of researchers say, that Excel is sort of like the universal solvent of research data formats. It's like water. It's everywhere in quantitative research. So it's worth noting that rather than shelling out money for one of these other packages at the outset, you may just want to use your Microsoft Excel application that you've already got on your laptop or your PC. Now, a number of economics researchers, natural and physical science researchers that I work with, they swear by SAS. It's sort of the Cadillac of analysis packages. SAS itself, there's a basic module, and then there are many add-ons and many sort of versions of the product. So for any sort of quantitative analysis, you can find an SAS add-on that will fit your needs. The problem is that SAS is generally fairly pricey. Now, SPSS started off as an open source application. Actually, it started as an open source application before open source was a term that we used. But it was back in the 70s that the forefather of SPSS was created, and it went from being simply an academic application used for social science statistics. In fact, that's what the name originally was for. SPSS stands for Statistical Package for the Social Sciences. It then became a private company. It was bought out several times, and now it was several years ago bought out by IBM. And IBM has tried to turn it into more of a business analytics application, something that can be used in marketing analysis a lot or for financial analysis. So it's sort of changed its tenor over the years, but it's still used quite a bit by social scientists, especially older faculty that grew up with SPSS as one of the only tools available for them to use. Now, UNM has a licensing agreement for SPSS, and I believe you can get it at the any of the UNM computer labs. And Philippe, can you get that here at GRC as well?
We have Stata and SAS here at the GRC.
Okay. So any of the computer pods, the labs across campus, I believe you can get SPSS. You can also buy it through UNM at the license rate of $79, and that's a one-time fee, so that's a good deal for that package. It does have a number of add-on features. It does have an Excel interface. It's very good. It has data collection tools that you can add on and collaboration tools so that you can do sort of team analysis across a large set of data. This is sort of what the SPSS interfaces look like. One of the long-known or long-appreciated strengths of SPSS is that you can sort of manage your raw data in a Excel-like spreadsheet format that's very easy to learn how to use. SPSS does not have really great visualization tools, but they're probably about on par with what you're going to get on Excel. Actually, I think probably Excel 2010 has some bells and whistles that the core version of SPSS doesn't. But you can do basic charts and graphs and different, all of the standard types, scatter plots and bar graphs and pie charts and so forth. SPSS, another strength that it's had that's appreciated by its users is that there's a scripting language that you can use to build custom analysis scenarios with SPSS. And it's actually one of the easier scripting languages that are available for data analysis. It's certainly easier than a couple of the others that we're going to talk about. But if you can't find an analysis scenario built into SPSS, you can pretty easily find an advanced user on any university campus who can write the script for you, or you can actually learn the script on your own. There's the documentation for it is very good if you purchase the package. As I mentioned, SAS is sort of the Cadillac of analysis tools. UNM does have a licensing agreement for it, but it's a yearly license, so it's fairly expensive compared to SPSS. I think it's like 120 if you're a student and 170 if you're faculty or staff. And you have to pay that yearly for the core SAS application. But as Philippe said, they've got it here and you can use it in GRC. It's used extensively in economics. In fact, I work with a number of the economists over in Anderson School, and they all swear by SAS for both economic analysis and financial analysis. And a number of researchers in biology and the harder, the natural sciences also, who need to do really extensive kinds of numerical analysis, also swear by it. So it also is reputed to have a rather good learning curve. So if you're going to start out with a statistical package, I might suggest you try SPSS first and then sort of graduate to SAS. SAS is known for having really great reporting capabilities, as you can see here. Very nice customizable reports. It also has a very advanced scripting language. It's got a more advanced scripting language than SPSS does. So if you need to do custom applications, custom data analysis scenarios, then SAS is definitely a great tool to use. I pulled this off of the internet, but it was a great sort of testimonial by a health sciences researcher in Texas, I believe. She says that she uses SAS to analyze prevalence data to determine the burden of diabetes in the state of Texas. She also uses it to analyze data and reporting to the Center for Disease Control for her grant requirements. And so I thought, those are two really good examples of how somebody who needs good numerical analysis capabilities uses the package. Let's go on and talk about data visualization. It's a huge field right now. There's all kinds of applications that are being developed, and there are new ones on the way all the time. This is a really big area for open source software development. So what's great about that is that you can get a lot of visualization tools for free or for very low cost. So here are some of the features that you need to look for with a visualization package. So being able to enable mapping, geospatial mapping is important. Being able to generate all of the standard types of charts and graphs, bar, pie, donut, scatter, line, etc., multiple axis. Also having 3D capabilities, so you can do multi-series data analysis and plot several lines of analysis at one time. Being able to link and embed the visualization into other applications is extremely important, because the visualization applications themselves are used just by the core set of researchers, and the general public doesn't have them. So instead of using the native file formats generated by these applications, you need to be able to export them to use in papers and reports and so forth. Now, if you need just basic charts and graphs, Microsoft Excel is a good package to use just to get started. You also have the pivot table capability, which gives a nice visual display of data. It doesn't actually visualize it in terms of graphical capability. But there's also, there's a whole variety of visualization tools that are available for different specialized purposes. If you go look on Wikipedia under data visualization, they list 45 different applications, and I'm sure that there's there's even more than that in terms of just major applications, not including specialty applications written for specific purposes. MATLAB is a mathematical visualization application, and if you are familiar with MATLAB, you might know that it was originally developed here at the University of New Mexico in the math department. The faculty member then went on to start the company, that MathWorks, that now offers MATLAB as a commercial application. MATLAB is very sophisticated, has a very high learning curve. So if you're just starting with visualization, you want kind of a soft visualization tool that's easy to use but gives great results. There's this really neat application called Tableau, which is inexpensive and is easy to learn. It's kind of got a drag and drop type of visualization interface, and provides really kind of stunning output and fairly easily. There are a couple of other tools here. Trend Analyzer and VizTrails are specialized tools that are used sort of in niche areas of research. There's also a free web visualization tool called visual.ly, visually, and there's the URL to it. You can use that for free, at least for basic purposes. You just have to go sign up for an account on their site, and they allow you to upload your data into their web application and generate your charts, graphs, and other kinds of visualizations online. Now for climate, there are a couple of, climate data visualization is one of the big niche areas of the visualization software category, and NCAR and the UV-CDAT are two tools or frameworks, at least, that are used there. So I just wanted to mention that if you grew up learning Excel, one of the previous versions, the charts and graphs were just really rudimentary and kind of boring. But Excel 2010 has really nice data coding capabilities, inline charts and graphs, and then formal reporting quality charts and graphs that you can use. That you can get quite a bit of bang out of your Excel buck. You can also get Excel at a student rate, either through UNM or through Microsoft directly. If you can, I think if you can upload your student ID, they'll sell it to you directly online at a substantially discounted rate. And as you can see in the background, we've got all of the standard types of visualization capabilities that you need for at least for school, if not for professional research. So here's a look at MATLAB. MATLAB is one of those products. It's kind of comparable to SAS, but in the visualization category. So you buy a core MATLAB application, and you can buy add-ons to do specialized functions, and there's a 20 or 30 different add-ons that you can purchase for. So you need to go look at the MATLAB site to see if they've got a special plugin that might fit your particular research need. Now, MATLAB is available at UNM Computer Labs. You can use it for free. You can also purchase a reduced fee. I don't have that. I didn't put that on that slide. Sorry. But yeah, I think UNM has a licensing agreement with MATLAB, and you can get that for us. Oh, actually, you can get it free. I'm sorry. Yeah, that's why I didn't have a price on there. Yeah, you can go to the it.unm.edu and download MATLAB, the core module of it, for free. And then if you are familiar with the Campus IT now provides online software training through a company called MyLinda. And if you look on MyLinda, I believe they have some MATLAB training. They also have some other types of training. I'm not sure it's for SAS, but I think they have SPSS training online as well.
Excuse me, Kevin.
Yeah.
Hey guys, just a reminder, we have SPSS here at the GRC as well. And I don't know if you know, but UNM subscribes to lynda.com. So if you go there, you'll have access to all the tutorials.
Right. Here's an example of the kind of visualization that you can get out of MATLAB. It does have, while its advanced features are a little more difficult to master, it does have a basic spreadsheet interface that you can at least get started with. That's kind of nice. And MATLAB also has its own embedded scripting language, programming language. It's kind of in between a scripting and a programming language. But this visualization here is a result of this code box here, what the code that was written here. So you can, with by learning the MATLAB scripting language, you can build custom analysis visualizations on your own. There are also a lot of folks you can find at any university, UNM or elsewhere, that know advanced MATLAB capabilities that you can tap in order to help build these things for you until you get proficient on it on your own. Now the next one we're going to talk about is Tableau, and like I said, Tableau provides a really easy drag and drop interface. It's used for business, economics, and the social sciences, and it provides really nice, stunning kinds of outputs. So if you're looking for something with a visual kick, the Tableau is easy enough to use. You could learn it rather quickly and get good results out of it. Here are two more Tableau screenshots. Tableau does have built-in geospatial and mapping capabilities. So this actually is a data set of 911 calls from the Seattle city area. And it has all of the basic chart and graph types, really nice report formatting.
Excuse me, Kevin.
So we talked about, yeah, go ahead.
Oh, just one last reminder, we're 5 minutes away and we still have the evaluations. So you'll be aware.
Okay.
Thank you.
There are a number of programming languages that are developed specifically for data analysis. Fortran was the original language. Fortran stands for Formula Translation. That was actually built so that a programmer could develop a special application for a specialized data analysis need. Now there are still a lot of Fortran programmers around, but the emphasis is really shifted to this language called R, which is an open source, meaning you can get the programming tools for free, application that are programming interface that's really quite sophisticated. It's a little difficult to learn. It's kind of should be on your advanced topics list. But if you're going to be doing numerical data analysis in your career, it behooves you to learn how to script in R. Very popular for quantitative applications. If you go to www.r-project.org, you can download the programming environment and the training and the documentation for free. It's very well documented. Here's an example of some R code that actually that outputs this Mandelbrot set. And I just have a static image here, but this code actually generates an iterative Mandelbrot set, so it'll cycle through various colors and animate as well. So it will do very advanced kinds of visualization and analysis functions. And then lastly, I just thought that this was pretty impressive. This researcher created this entire poster that he used for a poster session using a custom R script that he wrote. So he output both the formatting and the data analysis using R, and it's a pretty impressive result there. So that's the end of the presentation, and unless you have questions you'd like to ask, we should go to the evaluations.
Thank you, Kevin. Guys, feel free to ask any questions. In the meantime, I'm gonna bring the evaluation link for you guys, okay? It should show on your browser now. If you can't see it, I have the link here on the chat window. Thank you. Okay, guys, I'm gonna stop the recording now.